At 13, Demis Hassabis was one of the highest ranked junior chess players in the world. But then he stopped. No championships, no tournaments, he never became a Kasparov or a Magnus Carlsen. Here's the story of a chess master who fell second, but vowed to make the machines think instead. Here's the story of Demis Hassabis. He was 4 years old when he first saw his dad and uncle playing chess. He asked them to teach him, and soon enough, he was beating them both. At a very young age, it was obvious that Demis Hassabis is extremely talented. He was winning tournaments above his age bracket. And he even captained the England junior chess team for under 11s when he was only 9. For a moment in his life, the entire world was feeling like a cozy home. His favorite team, Liverpool, was always winning. He was beating older kids on one side and captaining them on another. But probably in the most defining years for a pro chess player, Demis started drifting away. In the 80s and 90s, pro players used to play against these physical chessboards that acted as practice opponent. So one day when Demis Hassabis was practicing, he just had this thought: how could anyone program this physical board to play chess at such a high level? He had this question in mind until he stumbled upon the book How Computers Play Chess by David Levy. He started studying and practicing the book front to back and developed his first AI program to play Othello. From then on, he became obsessed with the science of thinking machines. He thought, this is the ultimate tool. You can just solve intelligence and then use intelligence to solve everything else. Magnus Carlsen was 13 when he beat the legendary Kasparov and paved his way to becoming the chess icon that he is today. But Demis, maybe burned out, bored, or didn't care anymore, peaked at the age of 13 when he received the master title with the ELO of 2300, the second highest ELO in the world for his age bracket. Demis's world after 13 was very different. A constant progress after age 4 was replaced by a spiraling decline after 13. Progress or decline doesn't even mean anything because he wasn't sure where he was going with this. Amazingly, even his favorite football club, Liverpool, which was basically glued to the number 1 for as long as he could remember, never touched the cup again after he turned 13. Obviously, with chess moving down the ranks of his priorities, he excelled even more at the school and programming. So when he was accepted to Cambridge University at the age of 16 and the university recommended that he should take a gap year because he was too young, Demis decided to join Bullfrog Game Productions in the UK. He started out as a game designer on a game called Syndicate, but very soon moved to the lead programmer of the hit game Theme Park, which featured AI as a core component. The players were amazed that a game could react to their decisions. This game went on to sell millions of copies and helped Demis fund his computer science degree at Queen's College, Cambridge, where he obviously graduated with a double first when he was only 21 years old. Although by society's standards, Demis Hassabis is very successful at this point, but he didn't feel any closer to his ultimate goal of thinking machines. So after graduation, he wanted to apply his AI expertise to some real-world products, and games seemed like an obvious place. So he joined Lionhead Studios and worked as a lead AI programmer on the game Black and White, where you played as the god smacking or blessing everyone in a village. With the success of Black and White, he took the next step really soon. After just 1 year, Demis left Lionhead to found his own independent games developer company, where he made the highly ambitious political simulation game Republic the Revolution, which was even more tightly reliant on AI. And then The Evil Genius, another creative game based on AI mechanics. At this point, he was very good at AI engineering, but he knew it wasn't enough. He had to have a much deeper understanding. So he closed the Elixir Studios to study the only instance of real intelligence that exists in the world, the brain. In 2009, Demis obtained his PhD in cognitive neuroscience from UCL Queen Square Institute of Neurology and continued his research in the field of imagination, memory, and amnesia, co-authoring several influential papers published in Nature, Science, Neuron, and PNAS. In fact, his very first academic work published in PNAS was a landmark paper that showed systematically for the first time that patients with damage to their hippocampus, known to cause amnesia, were also unable to imagine themselves in new experiences. The finding established a link between the constructive process of imagination and the reconstructive process of episodic memory recall, a functionality that even AI models of today lack very much. Finally, it was 2010, my favorite part. It was time to bring it all together: neuroscience, games, and programming in the pursuit of the humanity's last invention. Demis Hassabis co-founded DeepMind with Shane Legg and Mustafa Suleyman to, quote, solve intelligence, and unknowingly kickstarted a chain of events that led to the creation of OpenAI, Anthropic, and pretty much all the major AI labs that exist today. In December 2013, DeepMind announced that it had made a pioneering breakthrough by training an algorithm called a deep Q network to play Atari games at superhuman level by using just the raw pixels on the screen. That achievement prompted Google to buy DeepMind for $400 million in 2014. Which in turn became the reason for the existence of OpenAI to counterbalance Google's absolute monopoly on AI. Demis probably knew, no matter how technically brilliant they are, AI excels on significant computation power, and there was no better partner on earth than Google. He somehow managed to not only join Google, but keep DeepMind's independence as an AI research lab. He was happy with the direction they were on, but DeepMind was nowhere near what Demis imagined it to be: a cutting-edge AI lab that could solve real scientific problems, not playing Atari games. The Google acquisition notched up DeepMind's ambitions, perhaps the most notable being the creation of AlphaGo. Although Go seemed like just another game, it was very special in the AI community. Unlike chess, the number of possibilities in Go explode pretty rapidly. This was the first time the system had to develop some sort of intuition, a deep pattern recognition that wouldn't fit inside any specific algorithm. AlphaGo learned by studying human games and playing itself millions of times. It managed to not only defeat the world champion Lee Sedol, but make seemingly bizarre moves like the move 37 that turned out to be a strategy beyond what humans have developed for the game. Go's complexity stumped computers for years. So when AlphaGo worked, it was probably the biggest tell that a new era of artificial intelligence was about to start, and it inspired so many to get involved. DeepMind published almost all of its cutting-edge technologies as peer-reviewed papers at a time when no one else was even close. They contributed immensely to the field, producing a number of award-winning papers. They made significant advances in deep learning and reinforcement learning, and even pioneered the field of deep reinforcement learning. AlphaGo was followed by a more general approach, AlphaZero, that could beat anyone at any board game. And it even won against AlphaGo in the game of Go. The chess prodigy that came second in 13 now had made a machine that was literally the best entity to ever play any board game. But this wasn't some sort of revenge on the chess community. No, he stopped caring about chess a long time ago. These breakthroughs were stepping stones toward his real dream: using AI to unlock the secrets of science. And for the first time, a real scientific breakthrough seemed within reach: the 50-year grand challenge of protein folding. Proteins are essential to life. They carry out nearly every function inside the cell, from transporting molecules to catalyzing reactions. Each one is made from a chain of amino acids, and the way that chain folds into a precise 3D shape determines what the protein actually does. In theory, if you know the exact amino acid sequence, you should be able to predict their structure, and from there understand the protein's function. But for decades, no one had figured out how to do it accurately. In 2016, DeepMind turned its artificial intelligence to this problem. This is a lighthouse project, our first major investment in terms of people and resources into a fundamental, very important real-world scientific problem, Demis said to The Guardian. In December 2018, DeepMind's tool AlphaFold won the 13th CASP award by successfully predicting the most accurate structure for 25 out of 43 proteins. While very impressive, AlphaFold 1 wasn't accurate enough, so Demis had to wait 2 more years to fulfill his childhood dream. And in November 2020, DeepMind announced AlphaFold 2. It achieved an overall error of less than the width of an atom, making it competitive with experimental methods, leading the organizers of CASP to declare the problem solved. 20 years of studying, experimenting, and building in the dark, and now he finally had a working machine that could solve a real-world scientific problem. Somehow, by God's design, Liverpool was also champion again, a title that they couldn't achieve since he was exactly 13. Probably the world felt like home again, this time with a lovely wife and 2 sons. Over the next year, DeepMind used AlphaFold 2 to fold all 200 million proteins known to science, and made the system and these structures openly and freely available to everyone. In 2024, Hassabis and John M. Jumper were jointly awarded the Nobel Prize in Chemistry for their contribution to protein structure prediction. Today, Hassabis is the CEO of Google DeepMind, probably the most advanced AI lab on Earth. He never became a chess champion, but he built a machine that could beat all of them. It wasn't about revenge. It was never even about chess. It was about curiosity and understanding. He didn't win at 13, but he never really stopped playing.